Hello guys, it's your guy Viera. Welcome back to my new tutorial. In this tutorial we are going to be generating the M&G code required for VMS project 9. So guys, we are going to be using MIL10 system. So let's get started. Solicam 10 new MIL10. I'm going to be taking internal, making sure that your unit of measurement should be inch. Go for the green check. So guys, now the CNC machine controller, very important. They are CNC controller actually used only for turning. Like the CNC controller has only turning in the sense that it can only be used for turning and it gives only one offset system. So you want to make sure that you have two offset system. As default, when I'm using this default CNC controller, it will give me only one offset, like only one coordinate, that is at the surface. But when I'm using MIL10, I want to make sure that I have two coordinate system, one at the surface and one at the back. Hope you got that. So you want to make sure that you change this controller and you take controller just like Intel 200. Even this controller at the bottom, URT, equally have two coordinate system. But right now I'm going to be working with Intel 200. So I take this, I go for coordinate system. I want to make sure that center of revolution face selected. Select face. Okay guys, so as you notice guys, we got two coordinate system, one at this face and one at the back side. So this will be our main spindle and this will be our sub spindle. I go for the stock definition. So I'm going to take cylinder, absolute coordinate, take model dimension. So right now I want to add some stock for the facing operation, 0.2. For the clamping, I'm just going to increase this by, let's say, minus 2.3. Okay, I'm good with this. Now for the external diameter, I'm just going to take 1.2. Okay, now internal diameter remains 0. So this is our stock or perfect. We go for the green check. Target, show target, all fine. Go for the green check. CNC controller, okay. Coordinate system done. Stock, target, all done. So the next step we are going to do right now, it's about the setup. Right clicking on the setup, edit setup, team preview. Okay. So I come on that main spindle, clamping fixture. I just click here, edit. So you want to make sure that your main spindle or your clamping is actually seated at the external diameter. So I'm just going to highlight this and I select this line. So you just want to play with these parameters in order to give your clamping a proper shape. The numbers of jaw, 3 jaw. So take this jaw backward, right? Because we are facing from this direction. So go for the green check. So we are working with Mach 1. So when we are using the back spindle, we want to make sure that this should be Mach 2. Okay, back to the main spindle. So I want to come to this line, pick Z, this line. Go for the green check. This is my workpiece, okay? And my jaw is somewhere here. So I just want to highlight this. By using the wheel of the mouse, I'm just going to increase it this way. So as you notice, the jaw is now holding the workpiece properly. So we are done with this, making sure that stock in should be activated. So now guys, we go to the back spindle. I want to make sure that I click on this and click on these 3 dots. Since this is actually back clamping, we should be clamping from this direction. I just want to highlight this and make sure that it's clamping within this diameter. So all good. We go for the green check, take in stock. So as you notice, it lifts the main spindle and it goes to the back spindle. So one thing I want to do is about the jaw rotation, the clamping rotation. So I want to flip this. So I'm just going to come under here and flip this. Oh, perfect. I want to highlight this point and then move it. Right now it's clamping this place, so we are going to be making the second operation on the back spindle from this direction. Right now it's in stock, right? So what happens is when this is in stock, all operation you are going to make, it's going to be performed on the back spindle because the back spindle is currently selected. So but we want to start our facing operation on the main spindle. So you want to make sure that you go back to the main spindle and you select in stock on the main spindle. So it leaves the back spindle, and what happens, it actually comes back to the main spindle as seen. Okay, so I go for my green check. So guys, my first operation currently will be facing operation on this point. So I go for solid cam turning, facing. Now I'm gonna take solid geometry, the surface, okay, oh, fine. I'm gonna check the direction, perfect. Modify geometry, auto extend to stack of stock activated, and auto extend to end of stock equally activated. Oh, perfect. Tool. So guys, I'm gonna select two tools, an extender tool. I'm gonna make sure that this extender tool should be of angle 60, and equally another extender tool of angle 35. Extender tool of angle 35 selected. Facing direction should be this. Levels, no levels, always safety distance. So I'm just good with this safety distance technology. I'm gonna take this. Okay, or fine. Surface finish, compensation on, save calculate. So I want to make sure that I'm working with Mach 1 position 1. So because Mach 1 position 1 is the main spindle. Then in simulation, facing done. So guys, the next thing we are going to do is turning operation, and we are going to turn it up to this particular end. So making sure that non-descending technology should be activated. Turning, solid geometry. I want to start from this point up to this point, making sure that the arrow begins from that direction to this direction. All good. Tool. I'm gonna take my extender tool of angle 60 degree. That is the first tool. Getting direction, this direction, levels or fine. Technology. I'm gonna be using long extender with a roughing pass. I'm gonna take distance, roughing of let's say 0.02 or fine. Step down 0.04. Semi-finish. No semi-finish, but rather finish pass of 0.08 or fine. Compensation on. Strategy, non-descending. Okay, save calculate. We are left to do this groove and this groove for the main spindle. And take this groove, solid geometry. I want to select, this is the chamfer, okay? So I want to select this part right up to this. Go for the green check. Tool. We're going to select a groove tool here. Square. Reduce this to let's say 0.02 and equally the width to 0.02. I want to make sure that this holder is actually removed. Go for the green check. Direction, this direction. Long extend and roughing or fine. Let me just check upon this roughing. I'm going to take distance of 0.02. Step over 0.04. Step down 0.008. Save calculate. The operation only goes on this groove. So the chamfer is left behind. So we have to make this chamfer. So next thing, I'm going to take save copy. So this operation gets to copy. Geometry. I just want to change this geometry. I'm going to take the groove from here to here. Tool, same tool, levels or fine technology. Go for the save calculate. So I have a chamfer at this point. I'm going to edit this operation. Wireframe, select geometry. This is the geometry. Tool. I'm not going to use a groove tool. I'm going to use an external cutting tool. Now, in this case, since the chamfer is a little bit deep, I'm going to make sure that I use an external cutting tool of angle 35. Simulate. Chamfer done or done. So guys, at this level now, based on our drawing, we have to put thread. We need to put thread here. Okay, so let's go thread. Now, I'm working at Mach 1 position 1. For the thread, I'm just going to select this surface and this surface. Okay, or fine. So from this point to this point. Tool. I'm going to select an external threading tool. Okay, external threading tool. I want to take rectangle. Now thread type, section B. Section B means we are going to be using half, and this 13 represents the tap per inch. So this is the unified method threading. I'm going to take UN, half, 13, or fine, straight or perfect, this direction, or perfect. So this is the right direction. Table, UN, you want to select 12, 13. Okay, thread finish, external finish, yes. I think we are pretty good. Save, calculate. We are actually done with the main spindle, right? We cannot actually machine this hole. If any attempt is done to machine this hole, even by using Mark II right now, there's going to be collision with the jaw. So what we have to do is we have to transfer the part. That is, we have to rotate the part. At this point in time, all the operations on the main spindle has been performed. We want to perform all the operations on the sub spindle. So in order to perform the operations on the sub spindle, we have to make a part transfer from the main spindle to the sub spindle. Now, in order to make a part transfer, we use what we call MCO, machine control operation. So you want to make sure that you are actually at the bottom of your tray. You should be at the bottom. Then you click on MCO, machine preview. So this is the sub spindle. Here is the main spindle. We have sub turret and the main turret. The aim is actually to move the sub spindle to this main spindle. Then the main spindle gets open, the sub spindle clamps on the workpiece, and with the main spindle open, of course, the sub spindle returns back in the home position while clamping the workpiece. Hope you got the idea. So the sub spindle has to move from this position to the main spindle and back to home position. Now, as you notice in the MCO, we got several operations. So speaking about the CNC operator, I'm just gonna drag it. Now, what happens? Looking upon the tray, if I save, calculate, you notice that the MCO gets added at this point. So what happens over here is when operations in the main spindle is being performed, at the point of the MCO, the programming stops. Now, CNC operator actually means that when the programming stops, the part transfer is going to be done manually. It is a manual operation. Delete this. So I'm going to show you guys how you can actually make the part transfer automatically. If the sub spindle have to move from this point to the main spindle, two things can happen. We could get collision with the sub tool turret, as well as we can get collision with the tool. We want to make sure that the sub tool turret is out of the way, and equally this tool is out of the way to avoid any collision. These are the steps you have to perform. This B axis is actually the main turret, and this rotatory is a sub turret. So I want to drag the rotatory to this position, movement, home reference, home reference. Okay, so nothing happens. This is because the sub tool turret right now is at home position. Movement. What I want to do right now is moving the sub tool turret to this position for safety. I will come on Z2, click on this 3 axis. As per my operator, it's 0, 0. Using the wheel on your mouse, you could actually move this turret just this way. As you notice, it's moving. So you need to move it up to safety position, and my safety position in my case is 0. I go for the OK. I just double click here. The next thing I want to do is select the main tool turret. Movement activated. I want to put this tool at safety. So I'm going to rotate it by, let's say, 0. Oh, fine. So it rotates by 0. At this point, it is at safety position. So you could either rotate it by 0, 90, or even minus 90. Make sure that it should be at safety position. I'm just going to click here. We want to make sure that the sub spindle moves to the main spindle. Track the main spindle. Now, since the main spindle is holding the workpiece currently, I want to use part move. Main spindle should be at home position. Back spindle, I drag. Movement, making sure home position. Then I'm gonna click here, drag down. So observe. Right now I'm gonna move the sub spindle to a safety location. Let's say minus 30. Okay, not enough. Minus 35. Not enough. Minus 37. Minus 37, it actually collides with the workpiece. So you want to make this go back. There should be some distance between the main spindle and the workpiece. So we are pretty good with this. Go for OK. That. You want to take setup lock. So the setup lock is actually the setup that was being defined in the main spindle when we were actually working with the setup. Hope you got that. Clamp. So what this clamp actually does is it opens the main spindle and then the sub spindle clamps. So we have to use close on stock. The main spindle opens and the sub spindle closed. We're going to double click this. I'll drag back spindle. Now currently the main spindle is open, however the sub spindle is closed. But we want to make sure that this sub spindle returns back to home position. Since the tool is on the sub spindle, we do not use movement, but rather we use path move. Home reference. As you notice, here is our piece totally placed and well positioned. So with this, you could just close the preview, save calculate, quick. We are done with the path transfer, so we can actually perform our operations on our sub spindle. Go for facing operation, making sure that we are working with Mark II, geometry, tool, external cutting tool, angle 35 degrees. This direction is not the right direction. We are facing from backward, so this should be the right direction. Technology, finish pass, backward, save calculate. No collision detected. Drilling, no coordinate system, tool. I have already defined my tool, so I'm going to be using a normal drill of 0.31 inch with a length of 3. Two direction, this direction we are working with the sub spindle. Levels, technology, drill start, 0.0, drill depth. I want to take this full diameter. I will use peg data, step down of 0.025. Okay, all fine, save calculate. The next thing we want to do is save copy, tool. For our chamfer, we are going to use a spark drill. Spark drill of 0.5. Okay. Now, how do we make chamfer using drilling operation? Drill start should be 0, drill end should equally be 0. Now, under depth type, you want to select this last one and insert the chamfer. The chamfer is 038, drill cycle, drilling, length, all fine. Save calculate. So with this, we are actually done with the programming. I want to bring to your attention that if you come under operation and you simulate the whole operation for the program, when all the operations on the main spindle has been performed, now the software takes about 12 seconds to actually perform the operation in the MCO. In order to make sure that when the operation on the main spindle gets finished, it begins directly with the sub spindle without wasting time, you need to do what we call synchronization. You have to synchronize the main spindle with the sub spindle. So in this tutorial, we will not speak much about synchronization. I will just show you guys a synchronization platform. You just have to open that platform, save calculate, and that is it. So making sure that you are on operation, just come under SolidCam Training, synchronize channel or channel synchronization. So in the further tutorial, we are going to be discussing about each part or features of this synchronization channel. As for now, you just want to save calculate. So now if you come under operation, simulate, verify, then go. Without wasting any time, we move directly to the sub spindle. So that is actually the function, or one of the functions of channel synchronization. Hope you got that. With this, we are done with VMS project 9. If you have any question regarding this project, do well to contact us by Facebook or by email, or even leaving a comment in the commenting box. Keep liking the video, keep sharing, keep commenting. Thanks a lot guys. See you guys in the next tutorial.